Hello everyone. Let's conclude our discussion on the physical design flow and the parasitic extraction. So the next step is to identify the SPEF header. So basically the SPEF header basically says that we have taken some assumptions over here. We have said that the slew or the threshold value, the rise transition or the fall transition over here is 100 picosecond, and the load is 150 femtofarads or 0.15 picofarads. So all these units, whatever we are describing over here, that has to be present somewhere in a specific format, in a standard format, basically in a SPEF format, so that it can be identified and used by other timing system or any other system. Okay, so that's where this SPEF header comes into picture. So SPEF header it's very simple. It consists, the contents of this SPEF header are something like this. It has got the star SPEF. So basically what is the standard for the star SPEF? So it says that it's an IEEE format 1481-1999. Okay, it's an IEEE format. Second, it specifies at what date was this SPEF was generated, or at what date was the parasitics were extracted. So in this case it was like 8th March. I just put the date on which I made this slide. So 8th March, Thursday, and 2015, and this is the time at which we extracted the parasitics. Okay, it has the star design name. Whenever anything attribute with star design, it basically specifies the design name. So in this case we have put a name, let's say vending machine. Let's say this particular circuitry that we are talking about, that is just some coffee vending machine. Okay, the vendor name. So vendor, there are multiple vendors in the market, and each vendor have their own parasitic extractor system or parasitic extractor tool. So this is where the vendor name comes into picture. This is where the program that the vendor is being using, that comes into picture, and this is the version of the program. So there are always incremental version being released by the tool vendors, and this is the incremental version numbers. Okay, just to keep a track of things. Next is the delimiter. So if you see in a very normal timing format, we see anything, if you want to describe a pin, it is given by a slash. For example, in this case it will be described as buff1/a. But in the SPEF format, we have given the delimiter as colon. It says that buff anything which is /a, that should be given by a colon a. So that's the delimiter that we are using. Then units, we are talking about units. So this unit, T underscore unit, is the time unit, and we have specified that the time unit is under picosecond. It's 1 picosecond. So this means that whatever time units we are talking about in this SPEF file, those are all in picosecond. Okay, similarly goes for star C underscore unit. So star C underscore unit is your capacitance unit, and it basically specifies that whatever load or capacitance we are talking about in this SPEF format, those are all in picofarads. So something like this one's 0.05 picofarads basically specifies it's a 50 femtofarad. Okay, so and the star R underscore unit, it basically specifies it's 1 ohm. So whatever has been the resistance values that is being described in this SPEF, those are in ohms. So it is 65 ohms, 76 ohms, and 55 ohms. And again there is L underscore unit, which is the inductance value. It's let's say 1 Henry. So we have not taken an example of an inductance, that will be taking in some other videos. So there is a provision for inductance as well in the SPEF format. Okay, and finally you have to describe what are your power nets and ground nets. In our case we just gave it a name, VDD and ground. So complete SPEF file with that small section of the circuitry, it will look something like this. This will be representation of your SPEF file. So this is the header section. This from SPEF till the ground nets power, from SPEF till the units are your header section. This is the description of your power and the ground nets. This is the name mapping that we did only for one port and one net. This is the description of the ports. This is the description of the net that we are taking as an example. This is the connection of this particular net with the ports and the pins and the internal pins. This is the capacitance, the distributed capacitance section. So D underscore net refers to as distributed net, and distributed, there are two kinds of nets basically, distributed net and R net, which is reduced net. So that's a different way we define a net. We'll talk about that in some other videos. So we have D underscore net, which is distributed net, and this is the distributed capacitance value, and we have we have the resistance value, which is again the distributed resistances value. Okay, so this couple of lines basically represent that small section of your circuitry. So just imagine if we try to extract even the parasitics for this particular complete circuitry, how big the file will be. It will take around 15 to 20 slides just to represent this SPEF file for this small circuitry. Okay, so imagine this size of this SPEF that it will be when we go for a multi-million circuit. Okay, so this was all about the parasitic extraction and the SPEF file. Finally, we take this particular SPEF file and do a complete timing sign-off analysis, and that's called as a sign-off analysis because that's the point where you actually infer your timing by putting the real wires RC. So now we have all the real clocks, we have all the parasitic being extracted, and you have this delay values. So you have the complete timing graph with you. Now with this particular timing graph, or with this particular complete timing information, you infer the setup and hold time. For example, one way is, let's say if you want to do a timing analysis for this section or for this section, a setup timing analysis, initially it was delta 2, the clock network delays will remain the same because we have added the real wire RC delay of the clock networks. In addition to the existing equation, there will be an RC wire delay for each and every. There basically RC wire numbers will be added into the equation. So the complete equations remains the same, except now there is something addition to it, which is the resistance and capacitance of the wires. Okay, and then this is your final timing analysis that we do, and we will be talking about complete timing analysis. We have talked a bit about the timing analysis, the basic setup, hold and transition timing analysis in this set of videos. We'll be having a complete course on sign-off timing analysis and power analysis. Let's not try to cover that in this set. Okay. And finally, that's all we had from the physical design flow point of view. In the next videos that we will be planning are the first of all are the placement and routing algorithms. So we talked about a very simple algorithm over here, which is the maze routing or the Lee's algorithm. There are more advanced algorithm techniques to connect to different points. There basically line search algorithm, there are Steiner tree algorithm, and so on. So we will be having a complete course on algorithms, on the placement and routing algorithms. We'll be having a complete course on design rule checking. What we talked over here are the basic 5 design rule check. We'll be talking about more, let's say it will be consisting of 500 to thousands of design rule check. We'll be having a complete course on that. We have talked about the parasitic extraction and the file formats in brief, but we will be trying to infer even more, even the complete IEEE format of the SPEF file in a separate video, and in those sections we'll be talking about the different file formats for parasitics. There is one more file format, it's called DSPF. So how different the DSPF is, how different it is from the SPEF. So we'll be talking about that in this set of videos, and there will be a complete set of lectures for sign-off static timing analysis. So this particular videos or this particular lecture will talk about the libraries, the min capacitance, the max capacitance, CCS libraries, and all those kinds of things. It will be talking about all of them, and the setup timing, hold timing, analysis, and so on. Okay, so this is a very important lecture that very important videos that we are planning to release soon. And finally, there will be a video on power analysis. Basically, it's a static, leakage, dynamic, switching, and all kinds of power analysis that we do. Okay, so that's all we had from this set of videos. Hope you liked the videos and hope you enjoyed watching them. Thank you.